Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see in detail about random forest algorithm. Random forest is one of the most preferred algorithm by many data scientists because it can be used for a number of problems like classification, regression, and it brings in so many benefits that makes it suitable to solve any data science problem, any predictive problem. So today in this video, we are going to see about all those details, what makes random forest most preferred algorithm for many data scientists. So first, we are going to start with why it is called as random forest. What is the reasoning behind it? And then we are going to see a simple example to see how a decision tree is built. So this would be a simple pictorial representation to make you understand like what is the concept behind decision tree. And then we will be seeing what happens in random forest, like how the trees are built. Then how random forest ensures that the trees are uncorrelated with each other, like what is uncorrelated and why it is really important. And then we will be seeing what makes random forest outperforms a lot of other algorithms, like including decision tree. When to use random forest and when not to use random forest. And finally, we are going to conclude by saying what are all the best features of random forest. And personally, random forest is one of my favorite algorithms. So what makes it favorite for me? So let's get into the concepts and then let's understand like what is a random forest algorithm and what are all the benefits offered by it. Let me share my screen and let's get into the concepts and understand what is random forest and what are all the benefits offered by random forest. So as you see my screen, so random forest is an algorithm that can be used for both classification as well as regression problem. So when I say classification, it can be used to predict various classes. For example, like whether a particular person would default a loan or not, whether an email is spam or not. So we can use random forest for these type of classification problems. And what we can do is we can use random forest for regression problems as well. Like how much loan a particular person would require. Based on various characteristics, we can make a prediction like how much loan, like this would be a continuous number, which is a regression problem. So it can be used for both classification and regression. Like there are a lot of algorithms which can be used only for either classification and some algorithms which can be used only for regression. But this is one of the algorithms which can be used for both types of problems. And this is an algorithm that is a classic example of an batting approach. So what happens in random forest, like why it is called as random forest? The reason is random forest is nothing but it tries to predict by building multiple trees. So when I say forest, forest simply means multiple trees. So same in case of random forest, what we are trying to do is we are trying to build multiple trees, like so many different trees, and we try to take the average of all those in order to make a prediction. Okay, so now why it is called as random forest? The reason for random forest is each and every single tree is built on various subsets of data, also various subset of features. If in case you are going to use the same data, the same subsets, like what would happen is the trees would look very similar. So no matter how much ever time that you run those algorithms, the tree would be very much similar. We don't need that because there is no use of creating the same trees and taking the average of it. So what we usually do is like what the random forest algorithm would do is it will take different subsets of data. Let's say you have 10,000 records, it will take like maybe 5,000 records at the first attempt and then maybe use out of, let's say you have 10 features, it will use maybe 7 out of those 10 features and then build a decision tree. Next time, maybe it will go for 8,000 records and it will use maybe just 4 of those features and then it will try to make the prediction. So this iteration continues, like each iteration, like each tree would use a different subsets of data and different subsets of those features, and hence those trees would look very different. And when you take the average of all those finally in order to make the prediction, it is usually much better. So that is the reason why it is called as random forest. So next time when someone is asking you why it is called as random forest, like you understand it. The subsets as well as the features are randomly selected, and then forest because it will build many trees, like many trees, and then it is called as random forest algorithm. So moving on to the second one. So first, before moving into random forest, we need to understand what is a decision tree, because what happens is in random forest we are going to build multiple decision trees and then we are going to take the average of it. So in this case, I have taken a simple pictorial representation to explain you what is a decision tree. If you are interested in understanding the decision tree concepts in detail, I will be tagging a video on the top, so you can go through it like it is a complete tutorial about decision tree, like how a decision tree is being built. So in this case, we are going to understand like the concept behind it. So here in this example, our objective is to identify all the squares and all the circles. So if you have a question like so after seeing this, like what I'm doing is I'm asking various questions like whether it is red, whether it has a thick border. If you have a question, why can't I directly use whether it is a square or whether it is a circle? You can't do it because that is what we are trying to predict. Let's say to compare this, let's say squares are spam emails and then the circles are like genuine emails. So while building an algorithm, we can just directly use whether it is a spam or whether it is an genuine email, because we don't know that based on the various features, based on like who sent those email and what content it has, we are going to predict it. So same in this case, like we want to identify the squares as well as the circle, but we can't just directly use it. Like we are going to use various features and then we are going to make the prediction. So in this case, in this example, what we are trying to do is first we are trying to separate, like try to create a branch based on the color. So if it is red, like move on to the left hand side as you see on my screen. If it is not red, if it is blue, like the other branch. So then what we are trying to do is, so then we are trying to see if it has a thick border or not. So using that, we again create a branch and then we are able to achieve the result. We are able to accurately identify all the squares as well as all the circles. So this is a very simple example. So this is how a decision tree would look like. So based on various features, we identify various features, we create branch, and it continues, it flows on until the leaf node is reached. So when the leaf node would be reached, when we are able to accurately or when we are able to make a decision. So that's when the leaf node would be reached. In some cases, what we do is we don't wait until the leaf nodes are being reached. We prune the tree, like we cut short it. We say like maybe up to 3 levels is enough for me. So that also happens. But this is what a decision tree would look like. This is how the trees would be built based on various rules or patterns in the data. So now, how would a random forest look like? For example, like this is an example. The source of this image is mentioned here. So as you see here, there are multiple trees. So each of these trees look very different. The reason for that is each of those trees are built based on different subsets of data and by using different features, and hence each of those trees are looking different. So this is how a random forest would look like. So here we have about 9 trees. So what we do is we consolidate all those 9 trees and then we use the rules generated based on those 9 trees in order to make the final prediction. So that's how a random forest would look like. So moving on to the next one. So how does random forest ensures that the trees are uncorrelated with each other? So as I mentioned, so let's say an original data set here, it contains 5 features and it has about 10,000 records. So each time when we build a tree, what happens is, as shown in this example, only a subset of the features are being used. We are not using the entire features and we are not using the entire data set. If we are going to do that, no matter how many times we run it, same decision tree would be produced. Like it won't be different from the previous one. So what we are trying to do is we are going to take different subsets of data and different subsets of the features, and then we are going to iterate, like we are going to build multiple trees. So what happens is each of those trees will look very different. Why? Because the data is different, the features are also different, and hence it can't be same. So that's how the random forest ensures that the trees that are being built are not correlated with each other. So when I say correlated, it means like both are looking very similar to each other. So it avoids that issue by using the randomness as well as by using the randomness like in both the data, in both selecting the data as well as selecting the features. So when we say Bardeen approach, what it means is, in case of Bardeen approach, it means that we are going to select a different subsets of data like each time, and then we run the model multiple times. So it is an ensemble model, because like we are running the model multiple times and then we are going to take the average of it. And then feature randomness is the feature where is a feature of random forest algorithm where we select different subsets of the features each time. So by both these combination, it ensures that the correlation is avoided. So moving on to the next one. So why random forest outperforms a lot of other algorithms? So the first one is it consolidates the prediction. So our prediction is not based on one decision tree or one algorithm. So we have built multiple algorithms using multiple different subsets as well as multiple different features of the data set. And when we take the average of all those things, what it does is it avoids the overfit. So let's say when we have one huge decision tree, like a really huge decision tree, it will be an overfit because it has been trained or it has been adapted to the rules or patterns that is present in the training data set. And hence, if the test data set is slightly different, what happens is it fails terribly because it is an overfit for the training data set. But by using random forest, what we are trying to do is we are avoiding the overfit by taking the average of multiple trees. So that is one of the benefits, and that is the reason why it outperforms a lot of other algorithms. The second point is automatic variable selection, as well as its ability to identify the features that are important in making the prediction. So both these makes it outperform a lot of other algorithms. So this is one of the important feature or important functionality of the random forest algorithm. So the third one is it doesn't make any assumptions. In case of algorithms like for example linear regression algorithm, what we do is we make an basic assumption that the dependent variable and the independent variable are linearly related with each other, whereas in case of random forest it doesn't make any of those assumptions. So we need not most of the times we need not do any transformation. We can use it as it is. It will look for various patterns, various rules in the training data set, which will be used in order to make the prediction. And finally, it efficiently uses all the features. Like if you have a data with a large number of features, many algorithms will be slow, but you need not worry about all those in case of random forest. If you have a large number of features, it is much better. It will try to come up with a better accuracy score or better prediction. So these are all the various reasons why a random forest algorithm outperforms a decision tree or any single algorithm. And the next one is, moving on to the next one is when to use random forest algorithm. So some of the characteristics present in the data would be a clear signal for you to go ahead and then use the random forest algorithm. So the first one is outliers. If your data set is having a large number of outliers, so then what happens is a lot of other algorithms might not handle the outliers efficiently. Like it will fail. So but in case of random forest, what it ensures is that it is not carried away by the outliers. It is able to outliers much better than other algorithms. So if your data set is having like outliers across any of the features, right, you can straight away go for random forest and then try how it is performing. The second one is if your dataset is having a lot of missing values, so which will again be a problem. There are many algorithms which can't handle missing values, but in case of random forest, it is absolutely fine with missing values. It can do much better prediction even if your dataset is having missing values. But what I would suggest is, just because random forest can handle missing values, it doesn't mean that you can run an algorithm like with the missing values. It is recommended that you identify various patterns and then you look for opportunities where the missing values can be suitably replaced. But in general, random forest is good in handling missing values. The third one is noise. If your dataset is having a lot of noise, some algorithms, what would happen is it will consider these noise as the pattern in the dataset, and then it will use these noises as patterns and make the prediction. So what happens is in the test dataset, like your performance will not be as good as it was in the training dataset. Whereas in case of random forest, it knows, like it understands what is and noise, because it is going to build multiple trees, and then over the time it will be able to identify the features that are important and the features that are not important. And then it has the ability to avoid the noises that is present in the dataset. So that's one of the reason. Like if your data is having a lot of noise, then like go for random forest. The next one is let's say like we don't want to use random forest to make the prediction, but we want to identify the variables that are very important in order to make an accurate prediction. So then what happens is, when we build the random forest algorithm, it will be able to identify the various features that helps in better prediction and various features that are not being helpful at all. So what we can use is, we can make use of random forest just to understand what are all the various features that helps in making the prediction, and only use those features like in our predictive model, like whatever it might be, whatever algorithm that you are choosing to use, that you can go ahead with it, but you can use random forest to identify what are all the various features that are important. The next one is, let's say if your dataset is having a large number of columns, if your dataset is really huge. So if you see these characteristics in your data, you can straight away go to random forest. Why? Because it can handle a large number of features and it can handle a large number of records as well. Like if your dataset is huge, either in terms of number of records or number of features, like you can straight away go to random forest and then give a try, see how well it is performing. So these are all the reasons why you need to use random forest to solve those problems. So now next one, why we shouldn't use random forest. Let's say you want to understand the relationship between the dependent variable as well as the independent variable. So then maybe random forest is not suitable. Like what happens is, in random forest, it will try to extract the patterns, but it will not help you in identifying the relationship between a dependent variable as well as an independent variable. So if that's the objective, maybe random forest is not for you. The second one is, if your test dataset is going to be very different from the training dataset, so then random forest is not suitable. Why? Because the random forest algorithm is heavily dependent upon the training dataset. What we try to do is, we try to identify various patterns that is present in the data, we try to build the decision tree, and if the test data set finally is going to be very different from the training data set, so then the model will fail, because it won't know the patterns. Like it has been trained based on something different, and then the data set that we have to make the prediction is completely different. So if you have a hunch that the test data set that is going to come is going to be very different from the training data set, then don't go for random forest algorithm. The next one is, if the linear relationship very obvious in the dataset. For example, let's say I will take a simple example. Based on age, you want to predict like the extent of gray hair for a particular person. So this is a typical problem which is linearly related. Like as the age increases, the extent of gray hair will also increases. So in case of a problem where the linear relationship is very obvious, so then it's better to use maybe linear regression algorithm or some other algorithm which is more suitable for linearity that is present in the data set. So those are all the cases where it's definitely a no for random forest algorithm. Finally, so random forest algorithm is good in identifying patterns in the data, but it is not good in establishing the trends in the data. For example, let's say we have a training data set where age is one of the parameter, and the general age that is present in the training data set is maybe between 15 to 50. But let's say the test data set has a lot of data where the age is, let's say, maybe over 70. In case of few algorithms, what happens is, it will be able to extrapolate, it will be able to identify the patterns or relationship between the dependent variable and independent variable, and hence if the test dataset is having a value that is outside the range of the training dataset, it will be able to establish that relationship, and then it will be able to make some prediction, whereas that can't happen in random forest. Like it can identify the patterns, but it can't extrapolate and identify a trend. So if your objective is to establish a trend, so then random forest is not suitable for you. You need to go for some other algorithm. So these are all the various reasons when you can use random forest and when you can't use random forest. So moving on to the next one, like which is the final thoughts. So random forest is one of my favorite algorithm. So what makes it so special for me is it can be used for both classification and regression problem. And random forest is an example of an ensemble model. Like ensemble models means that we are trying to combine multiple models. So most cases, ensemble model usually outperforms like any single model. Why? Because we are trying to build multiple models, like in this case multiple trees, and then we are taking the average of all those, and hence we straight away avoid the overfit, and the performance generally improves. So that is one of the reason why it is why it is one of my favorite algorithm. And the second one is random forest helps to store the importance of the features. Let's say we have a large number of features, so we can't use all those features. So what I can do is I can use random forest and then identify what are all the various features that is important, that helps in improving the prediction, or that helps in making an accurate prediction. And what we can do is we can just use those features in order to make the prediction, maybe using some other algorithm as well, like if it is more suitable. The next one is random forest works well with a large amount of dataset, and a dataset which has large number of columns as well. So that's one of the reasons why I like random forest. And finally, it also has an option to visualize. Like if it is a decision tree, like it is just one tree, we can easily visualize, we can edit the patterns. But even in random forest, if we are going to limit, let's say with 10 trees, usually we try to build like hundreds of trees. But if in case we want to limit with a smaller number of trees, so what we can do is we can print all those trees, and then we can see the patterns that is present in those trees. Like what I would say is, even if you're going to end up building hundreds of trees, you can maybe try a small sample and then see how the trees are looking like what are all the various patterns that is present in the data. The advantage of visualizing the tree is we can easily translate that to the business stakeholders. Like the business stakeholders would be able to easily understand like what's happening. So it is not like a complete black box, and the business stakeholders are not able to understand they are not able to make out what's happening like in the predictive model. Because we are using the patterns and rules, it will be easy to translate that to the business stakeholders and make them understand like what's happening. So these are all the various reasons why I like random forest personally. So far what we have learned is we have learned what is the reasoning behind random forest, what are all the various benefits, when to use it, when not to use it. I hope you have learned something new today, and if you have learned something new, please give a thumbs up and subscribe to my channel. If you think this video will be helpful to any of your friends who's trying to get into data science or learning data science, please share it with them as well. And that's it for now, and see you in the next session. Bye.